So the way we're going to do this today is that we're going to start with a round of lightning talks. We're going to talk about all kinds of automated testing technologies, infrastructure, whatever we have, some demos.
Suppose you want to write some desktop test cases for like an MApplet, for example. You want to check what happens if you have a 3G connection and a Wi-Fi connection at the same time. Or you want to write tests for the message indicator and make sure that it pops up a notification when the telepathy stack sends a message to you. Or like a bug that a lot of us encountered on the Nexus 7, if you press the power button and click on suspend, that it would actually suspend instead of doing nothing. And the common part of all of these is that you want to set up some DBus services on your plumbing stack or the telepathy stack or whatever really in a well-defined manner, and then run your desktop bits against this and see what happens. So this is why I wrote a little project called Python DBus mock, which allows you to do exactly this. So you can create a little sandbox with the fake system bus, a fake session bus, and then create arbitrary objects, DBus objects and servers inside there, call arbitrary signals, and like add methods and so on. So for example, I wrote a little script to set up a mock UPower environment. So this would, let's start an indicator here. Bloop. So this would set up a fake UPower, and I configured the mock to just show me the method calls that the client does. So I see that my fake indicator, where is it? Ah, there, And the projector, of course, messed up all my, here, okay. So we have our session indicator in the mock sandbox here. And if we request a suspend here, we see that our mock UPower, like on our mock UPower, it called the suspend method. If I was doing the same thing on the real indicator here, it would, of course, actually suspend my machine. But suspending my machine is a rather unfriendly thing to do in your test suite, so you really want to do this kind of thing on the mock. And likewise, I also told this test case that I've got an AC attached, which I really don't. So, but I mean, at the moment, my desktop session in this mock is convinced that I have got an AC adapter. So you can run tests against this, for example. And the next test case, I changed my mock UPower to pretend I've got a critical battery. So like in my real indicator, you see that my battery is just fine. But if I were to run test cases here, then, for example, if I was to run a GNOME settings daemon in my mock environment here, then it would freak out and say, "Ooh, you're out of battery," and request a suspend or hibernate from my mock UPower. And I was writing a real-world test case for this to demonstrate that GNOME settings daemon actually tries to suspend your machine if you have two batteries and only one of which is like on critical charge. Yeah. So yeah. So how does that look like? So basically, in the beginning of our test case, we start a mock session and like a fake session and a fake system bus here, and then tell the mock to create an object which is called org-reader.upower, and then we can create a couple of methods on that interface, some of which are returning a value, some of which don't, and we can add a couple of properties here. And then we've got the actual test cases here. So in the first one, we create a mock AC object, which has a couple of properties. So type 1 in UPower speak means it's a AC power. And in the second test case, we add a battery with a couple of properties like 2% charge and 30 seconds left. And then once again, where I just called the shell here, you would do the actual tests, of course, but it's more interactive that way. And observe that none of this requires root power, and none of this really interacts with your actual system. So it's stuff that we can run in make check and JH build and server environments, and it's really, really safe to your actual machine. So if you have questions, then just approach me. So this is going to be packaged in raring. So right now it's in a PPA and in a branch, but it's easy to get also with PIP. Thank you.
This presentation is about Checkbox. Well, not directly about Checkbox. It's about some of the tests that we have in Checkbox. So So Checkbox is a testing tool that a few teams in Canonical use. It's geared towards hardware validation. So it supports running manual and automated tests. And it also has features to gather hardware information from the system that the tests are running on. And one of the things I wanted to mention about it was that it contains a whole bunch of test scripts, basically, that are quite flexible and could be reused by other people in whatever way they want. So I'm just going to go over like a selection of the tests that we have that could be useful to other people. So we do wireless testing, okay, and we have a couple of scripts that are interesting. So we have one called create connection, right, which basically it creates a connection in Network Manager. Let's see what's available. Okay, so I'm not going to be able to demo it because there's no network with a sane name available that I can connect to. If only I could mock it, yeah. No, well, the level of testing is actually at the highest level. So it supports creating WPA or open security connections. And it also, so you can provide it with the type of security to use and the key and the SSID of the system. And it'll create a connection in Network Manager and actually bring that connection up. And then you can do whatever you want with it. There's another interesting script which actually, anytime you run it after the system is suspended, it'll tell you the amount of time that the wireless connection took to associate again. So there's a little problem with it at the moment in that it only runs on some wireless chips because they basically report that they have associated again in different ways in the kernel logs. There's one we have for graphics testing, which is pretty interesting. I hope this works because it's on an external display. So basically, it rotates the screens 360 degrees in steps. Yep. Whoop. Upside down. Yeah. Right, and back again. Okay. Audio testing. Actually, we have another test which is really interesting. So basically, if I re-enable the sound on my system, I can break all your eardrums. So what it does, So what it does is it basically plays a sound from the internal microphone, and it tries to detect it on the, plays the sound from the internal speaker, tries to detect it on the internal microphone, and if it can, then the script passes. So whoa, it failed. Okay. Microphone seems broken. Okay. No, it's probably something to do with the acoustics of the room. So it probably didn't record the right frequency. As you know, demos are prone to failure. And there's another one which manipulates pulse audio settings, such as volume, mute status, and the default sync and source, which is useful. You can use it in conjunction with the audio test, for example, to play a sound. You can switch to the USB headset, set the volume to the highest level. You can mute the audio or not. So lastly, this is something that's really interesting. These are two very cool scripts, which one of them, I wish I had a USB device. Does anybody have one? A USB stick? It basically waits for a period of time and detects the insertion of the device. And one of the interesting scripts about one of the interesting things about this script is that it actually uses UDISC 2. So it was heavily reworked in Quantal to use UDISC 2, which was quite challenging. It also supports detection of USB 3 devices, and the meaning of that is that it actually detects whether they're reported as USB 3 devices and not maybe as USB 2 devices, as can happen. There's also a separate script called removable storage test, which has the same options as the watcher script, but it actually it transfers files to the specified storage and checks whether that was successful. So, yep, that's the end. The point of all this was just to basically illustrate that on any installed system in Ubuntu, there's this directory which contains a whole bunch of different test scripts that can be used by anyone for using in their testing. So it's there if anyone needs to use it. Okay? Thanks.
My name's Tommy Richards. Some of you know me. There's some very small print on the screen there because when someone asks me to do a lightning talk, I take this as an opportunity to rant at you for 5 minutes. So I'm going to talk about something that's very near and dear to my heart, but in the process I may offend some Unity developers in the room. So we'll just take this off and pretend that, I don't work here. So I want to talk about testing because this is a testing event, and I want to talk about levels of tests, right? When you write a test, you can say it's a low-level test or it's a high-level test. You can classify your testing methods in many different ways. And I want to talk about the very low end of the spectrum. I want to talk about unit tests. And unit tests, if you look in any traditional computer science textbook, the definition is something like this. They'll say, well, a unit test is a test that exercises a unit of code. And that's a pretty terrible definition by anyone's standards, right? For a start, we're using the term that you're trying to define in the definition itself. And lots of people come away from that thinking, well, okay, I understand that a unit test is some sort of reasonably low-level test, but not really have any great idea about what a unit is. And I'm going to put it to you, this is the Tommy Richards' personal opinion here, that a unit is a single point of failure, right? That is how you should be thinking about what a unit is inside your code. That is, if your test can fail in more than one way, it's really not a unit test, right? It's an integration test or whatever else you want to call it. In order for it to qualify as the Tommy Richards gold standard certified, thumbs up seal of approval unit test, it has to be able to fail in exactly, at most, one way. There's two big reasons why you want this in your unit tests. The first is that when you branch trunk or when you start hacking on some small piece of feature, you're going to run your unit test suite afterwards, and assuming that you have 100% unit test coverage, if you've made a mistake, you should hopefully see this, right? This is, I'm assuming everyone can understand this. If not, this is what you get when you run Python unit tests, right? Dots mean pass tests and F means a fail test. You want your one mistake, or you want your mistakes to correlate to one failed test. What you don't want, what's really not helpful, is this, right? Because now, and this is a small test suite, imagine a test suite that has 1,000 cases or even 5,000 cases. Here you have lots of tests to look through to try and unpick and work backwards to the one, the one mistake that you've broken and you have to fix. So that's one reason why you want to be more rigorous about the size of your tests and the size of your code. The second reason is that if you do this, you will write better code. Right? This is my bold assertion. Your code will be more readable. Your code will certainly be more testable. It'll be more modular. It'll be all these things because you have to keep your functions or your methods very small and very compact so that they can be easily tested. If you do this, if you have a unit test suite that follows these rules, you can start to measure code coverage, and you can start to have a code coverage metric that actually makes sense. Right? If you wrote really high-level unit tests, code coverage isn't actually that helpful for you because it doesn't tell you how likely you are to actually pick up on one specific failure with the run of your unit test suite. Now, that's not to say that unit tests at a low level are going to be the be-all and end-all of your testing strategy. Right? If you have this, if you have 100% test case coverage with very small, low-level unit tests, you will be able to spot individual breakages in individual methods or functions. What you won't be able to spot is breakages between methods, right? You won't be able to spot when an interface changes in one place and it's not updated somewhere else. You won't be able to spot those places where, you know, the format of the information that you're passing around your internal system changes. So you still need integration tests, and you still need functional tests. And if you need functional tests, you should come to the autopilot talk tomorrow. And if you'd like to talk about this or anything else, please come and talk to me. I try not to bite. Thank you.
All right. So just want to quickly talk about LXC and how you can use it to run your tests probably a lot faster than you can do with any kind of VM. So for any of you who don't know already what LXC is, it's basically containers. So you can see that as true roots on steroids, basically. It has the same impact on your system as true root, but it comes with a fully separate network stack, full network bit namespace. So it really looks like a full standard system within the container, but is actually running on the same kernel and has the same performance impact as the true root. Now I just want to show what I'm usually doing on my laptop when doing Ubuntu development. So one thing I'm always making sure on my machine is that I don't actually have any development library, and I don't actually have any foreign architecture packages on my system. For that, I just use containers. So if I go into my LXC directory, there, right. I'm not sure if that's readable. Maybe a bit bigger. That's hardly better. One sec. Just fixing that stuff. Right. There we go. So what I have basically is a bunch of containers, one for every release of Ubuntu at least, and well, one per architecture per release of Ubuntu. For those that actually support weird architectures. So LXC lets you easily create those. Those are basically base containers. I never actually touch those. Instead, what I do is, if I switch to this one, and get it back to a decent size, I use a command called LXC start ephemeral, which lets you use an existing container, set up overlay FS on top of that, and then lets you work inside an overlay FS. When you're done, you should run a container, everything is wiped. So let's say, I haven't actually tested that one, so let's see if that works. If I try rearing army-l, yeah. Python 3.3, not so much. Right. So you just need to wait a few seconds to actually have upstart and everything starting, and then you get a login prompt. You can get for access, and inside there, you can see that you have just a few processes on a clean rearing system running army-l. So then you can run all of your tests in there, and when you're done, you just shut out the container. Takes a few seconds, and everything is wiped, and you're all good to go. The other nice thing is that as it's running on tempfs, it's pretty fast. When I'm doing Ubuntu upgrade testing, I can basically install a full Ubuntu desktop and upgrade it to the next release within 3 minutes. So that's pretty useful for that, instead of waiting for hours for a VM to be done with everything it's doing. Another thing that some people may not be aware of is that you can actually do accelerated graphics from within a container. So if I start my container for weird 32-bit graphic stuff, so I'm from within a container. Basically, my X socket is bind mounted within temp X11 Unix. And dev DRI is also bind mounted. So if I start some tool in the container that does GL, it's going to be able to access my graphics card directly and my X server. If you don't want it to run directly on your X server, you can start Xephyr on your laptop, then export display equals :1, for example, and run that in a limited X server. So still don't need any VM for that. Quickly, one last thing, just shutting down this one. So one of the work that was done for the past cycle is we actually have now an upstream LXC Python module that you can use to control containers. So you can import LXC, you can get a container instance for some container, you can check the state. So this one is currently running. So as it's running, I can check what its IP address is. You can get a console, so if you want TTY2 for that container, you can attach to it. You can also access any of the actual configuration for the container. And you can obviously stop the container and check it's completely stopped. So that's really an easy way of accessing your container, automating everything from there. You can easily start a container, run get IPs, SSH to the container within the container, run whatever test you need. When you're done, you stop it. You run .destroy to wipe it completely, and you're done. So I really encourage everyone to play with LXC. If you have any question, if you need anything implemented in upstream LXC, just come talk to me, and I'll see what can be done. Thanks.
Anybody else?
Does this work? Oops. Is this working? Oh, okay. Oops. Okay. So hi everyone, I'm Daniel. Work at the hardware certification team in Canonical. And this is going to be one of those boring, ranty presentations. And yeah, what I think is pretty obvious is that we should have a centralized testing repository. So basically, there's a big focus on automated testing in the Ubuntu community, as we can see here. I mean, the main focus of this gathering is to talk about automation and stuff like that. There are many teams that are doing automated testing. QA is one of them. The Unity folks are also doing it. Hardware certification also has some automated tests. Even the Linaro folks with Dava. Even people programming for the kernel. And even end users helping with testing may benefit from automated tests, right? Okay, so basically, it's something that we should strive towards. I was at the Utah training sessions today, and I learned how to write a Utah test. This is an example of a very simple test. By the way, yeah, those sessions are very interesting, so if you're interested in learning how to write test definitions for Utah, I highly recommend that you go to those sessions. They're very well planned. So anyway, as you can see, this is a very simple test, and it expresses basically the meat of the test is the command that it has to run, the fact that it has to run up as a particular user. And basically, well, it expresses things as dependencies, perhaps the timeout, some setup and tear down steps that, well, that's something that if you work with unit testing, you're familiar with. In the case of Utah testing, a test's name is determined by the name in which the test's files, the name of the directory in which the test's files are stored. So there's no explicit test name. The reason I mention this is that we're going to next look at another test that has a specific name for it. So this is an automated test description for Checkbox, which is the other tool I'm most familiar with. As you can see, it pretty much expresses the same things. It has a name, so that's why I mentioned the fact that Utah doesn't explicitly specify a name within the test itself. It has some dependencies, it has some requirements. It has a user under which the command is going to run. It has the command that's going to run, the same as on the previous one, you can see here. And it has, well, just a textual description. Checkbox doesn't have explicit per test setup and tear down steps, but that's basically, it's by design. I mean, that's what the tool works for, but that's just some meat and potatoes to the test, right? So what I noticed is that they're pretty much doing the same. We're expressing automated tests in a way that has been converging toward the same set of features. I mean, it's telling the fact that a tool that has been around for a long time, such as Checkbox, has a very similar syntax to Utah, which is a tool that had a lot of thought going into its design. So yeah, this is very telling. I mean, we're converging towards expressing automated tests in the same way. Implementation of many of these features is bound to run into the same issues. I mean, the run as feature of Utah probably will present the same issues as Checkbox's user feature. So there's a lot of common knowledge to share as far as implementing these features in the test harness, but the fact is the tests express the need for running as a particular user. So yeah, the main difference is in the test harnesses or runners. These are use case specific. I mean, Lava fits a different use case than Checkbox, which is also different up to a point from Utah. So that's where the most of the difference is. But the fact is that the test cases themselves potentially are not that different. So the idea of having a central repository is to avoid replication of work. Basically, it's something that you shall not repeat yourself. And in my opinion, basically the point of this rant is saying that I think this can potentially be achieved by, I'm not going to say how to do it right now because I don't know, it's something that we have to work for. But the first thing is communication. There was this thing called the vendor team in which hardware certification and the CQA folks collaborated in creating a lot of automated tests, and the key thing that came out of that was that we need to communicate. Basically, teams working in isolation are going to produce tests that will replicate work. Collaboration, of course, once you have communicated what you need to do, teams working together are better than just one team implementing and the other just saying, oh, wait, I'll wait for it to be ready. We need centralization, basically, for storing the tests. Oh, my time is up. If you want to say, get out. Okay. Anyway, so centralization, basically, where and how do we store all these tests? There has been some work done for this. I remember tools such as Litmus, such as, what was it, Case Conductor? And there's this other tool called Testopia. So there has been some work done as far as where do we store all these tests. I don't think that any one tool is the best one for the job, because otherwise we'd probably be using that one. And then once we have all this, we can profit from a centralized test of repositories of tests from which everyone can just pull the tests that they need and run them using Utah, Checkbox, anything they need. Oh, actually, this is the one thing that we need to work towards, planning how to do this and committing all the teams and all the folks that are creating automated tests. We should try to commit to actually working together towards having a universal set of tests. That's it. Thanks.
So my name is Sergio. I work within product strategy, QA as well. And basically what I want to talk about is something we have in our Jenkins infrastructure. It's called PBuilder Jenkins. It's something we have just to automate and easily just create packages before we deploy them into the PPAs we have, and run a lot of cool things. So basically what PBuilder Jenkins is it builds our recipes for our bazaar recipes depending on well, if we have packaging branch, inline packaging, it does all the magic there. And the other thing that is cool that it has is basically kind of like 200 hooks that we have. It's kind of like a hook repository. Some are dynamically created from some private PPAs, and if you have access to those, you can probably generate them as well. And it's not that all the hooks are run from a standard directory, but we have this thing where you can just choose the hooks you want to use, and it will basically run those set of hooks and create a build. Some hooks are simple as generating coverage, like what for the stuff that Alan was trying to show, and it gets all the coverage stuff on Jenkins, and you get the neat charts with cobertura, and other ones enable unit testing. Then we have some hack hooks, which are kind of special. The hack hooks are when packaging branch is broken. We have these hack hooks that run before the actual PBuilder instance that kind of modify the repository to, well, hack it and make it buildable with what we have in the packaging branches, since most developers can't access those branches. Well, in my case, I prefer native, so I don't, inline, sorry, just to speed up development. So it's not a problem I see, but most people have it. And oh yeah, that's it. It's PBuilder Jenkins. It's two-sided. It's Python one side, and then it's Java. It's a Java plugin on Jenkins, and it's very simple and easy to use, and it's probably somewhere on Bazaar, so you can just look PBuilder Jenkins and Jenkins PBuilder plugin, and you can probably set it up and try it and complain about it, and that's it. So we try to use we try to get this done there using the best practices in PS, and after a lot of talks with many people that know about packaging and all that stuff, we got that kind of settled out, and well, now that's it. That's all.